Hello, good morning, and thank you for joining us, the Energy Efficiency in Rack Technologies team, for another one of our exciting webinars. So before we start, I would just want to go through a little bit of housekeeping rules. The chat function has been disabled, so we kindly ask that participants direct all their questions to the Q&A box. Also, this webinar is being recorded as well as live streamed to Facebook and will be available for viewing and sharing after on the project's YouTube channel and Facebook page. The links will be shared in the chat for you. So we hope you do enjoy our webinar today, and I'd like to take this opportunity to hand over to Dr. Marissa Gowrie, the Deputy Environmental Manager at the Ministry of Planning and Development's Environmental Policy and Planning Division. Dr. Gowrie.
Thank you very much, Rebecca, and just making sure that you can hear me.
Loud and clear.
Okay, wonderful. So good morning, everyone, and welcome to yet another installment of our environmental webinar series hosted by the Environmental Policy and Planning Division. And basically these series that are part of the Ministry of Planning and Development's outreach and, trying to share all the information that on what we do. These sessions are aimed to raise awareness on various environmental topics. And today we are having this session also in commemoration of World Environment Day 2022, which will be taking place on Sunday coming June the 5th. So for those of you joining us for the first time, and if you've heard this already because you've been with us, just indulge me a little bit, just to share a little bit about what the EPPD, the Environmental Policy and Planning Division, does. We provide guidance on the formulation of national environmental policies, programs, and all the things related to various sectors of the environment, such as climate change, ozone depletion, chemicals and waste, biodiversity, so that we are very much involved in the sustainable development trajectory of the country. You can find out more about what we do on our social media platforms, such as Instagram and Facebook, using the handle @EPPDTT, or on our blog, Green Days at EPPD, or on the National Ozone Unit's blog, and you can get that by searching Trinidad and Tobago National Ozone Unit. So to tell you a little bit about what the National Ozone Unit does, essentially this country became signatory to something called the Montreal Protocol in 1989. And since then, we have been doing various activities to implement the obligations under the convention that deal with phasing out chemicals that are damaging to the ozone layer, such as those found in refrigeration and air conditioning, such as refrigerant. So we're talking about things like, you may remember CFCs, chlorofluorocarbons, that we would have phased out since 2008 under the work that we've done under the Montreal Protocol. And we also have been currently phasing out HCFCs, or R22, again, a refrigerant. And quite recently, the country has also become signatory to the Kigali Amendment that will be addressing something called HFCs, or hydrofluorocarbons, and our action of phase down for these chemicals will begin in 2024. So basically, under all that we do in the National Ozone Unit, we would have seen an opportunity within the Global Environmental Facility a couple of years ago, where there was some unspent funds in the sixth replenishment of that GEF, Global Environmental Facility cycle. And together with the United Nations Development Program, the ministry, together with various stakeholders in the refrigeration and air conditioning sector, would have developed a product that basically aims to improve the energy efficiency in the refrigeration and air conditioning sector by basically introducing more environmentally friendly technologies in this area. So our basic aim is really to transform the market and really to create that change in terms of sensitization on what people choose the technologies in refrigeration and air conditioning, to ensure that they choose the type of equipment that are better for the climate, better for the ozone, and use refrigerant and technology that is really something that we can be sure we are not causing harm to the environment. So today's webinar focuses on a specific aspect of this, which deals with passive cooling. It's another concept of sustainable cooling. And as we all would have noticed, as climate change becomes more and more evident and we have increases in temperature, the need for cooling has increased. But we want to ensure that we approach cooling without warming, because some of the refrigerant that I spoke of, the HCFCs, the CFCs, they not only deplete the ozone layer, but they also contribute to climate change. So the action that we take in the sector will not only help protect the ozone layer, which is a natural shield that surrounds the Earth, 2 to 3 millimeters thick, and it filters UV rays from the sun. So it has a very, very important function. And these refrigerants cause damage to that ozone layer, but it also causes climate change because it contributes to a blanket that forms around the Earth when these gases go up into the atmosphere that traps heat and causes what we know as global warming, rising sea levels, increased temperatures, increased natural disasters such as hurricanes that we would have seen in our region. We would have been witness to a lot of flooding over the last couple of years. So our action of what we do in refrigeration and air conditioning can greatly affect how we contribute to preserving our ozone layer and protecting our climate. So I don't want to take up too much time. I'm very much looking forward to what our speakers today have to tell us and how we can approach cooling in a manner that is more environmentally conscious and better for us all, not for just this generation, but for the generations to come. So I would now like to pass it over to Jamil, who's going to tell us a little bit about our speakers this morning. Thank you. And again, welcome and happy World Environment Day.
Hi, everyone, and happy World Environment Day to each and every one of you. I am Janelle Huggins. I am the Project Finance and Administrative Officer with the Energy Efficiency in RAC project. And I have the pleasure this morning to present our lovely speakers. They're very dynamic. They're really experts in their field. So we're going to start with Mr. Ronaldo Jalil, who is no stranger to this platform. You've heard from him many times before. Ronaldo is an energy efficiency and renewable energy professional with over 7 years of experience as a project engineer and consultant for the development of sustainable energy projects. He has developed training courses in energy efficiency and renewable energy to impart to persons the economic benefits of identifying potential energy saving opportunities and implement strategies to reduce energy use, minimize costs, reduce greenhouse gas emissions, and improve business performance. Ronaldo is always willing to work towards a greener and more economically sustainable future for Trinidad and Tobago and the Caribbean. Our second speaker is Mr. Stein Carrington. He is the principal architect of the Stein Carrington Architects Limited, a full-service design consultancy based in Trinidad and Tobago, a registered architect with the Board of Architecture Trinidad and Tobago and member of the Trinidad and Tobago Institute of Architects. He is a creative designer with a pragmatic vision of design and its implementation. Stein is currently the treasurer of the Trinidad and Tobago Green Building Council 2021 to present, and has served as a treasurer of the Trinidad and Tobago Institute of Architects from 2018 to 2021, as well as a board member of the Trinidad Transport Board, a presidential advisory board of the Ministry of Roads and Transport. Stein holds a BSc in surveying and land information from the University of the West Indies, St. Augustine, and a Bachelor of Arts in Architectural Studies and a Master of Arts from the University of Technology in Jamaica. And finally, we have Mr. Mali Kwamina, who is Mega Interiors and Construction Limited's Chief Executive Officer and is a member of the UNFFC System Staff College. Under Mali's leadership, Mega Interior and Construction Limited grew from a startup company back in 2016 to an ESG enterprise in 2021. Mali is a fine craftsman with green construction knowledge. Mali Kwamina climate change advocacy refers to a wide variety of resource-based solutions, training, and activities. It includes certain forms of environmental law and policy, careers with mainstream environmental groups, and work with other advocacy groups, such as the World Wildlife Fund and the Trinidad and Tobago Green Building Council. So without further ado, I want to present Mr. Ronaldo Jamil, who is going to talk about passive cooling with us. Ronaldo, off to you.
Hey, pleasant good morning to everyone. Thank you for joining us in this presentation on passive cooling. Today, I'm just gonna give you a general understanding of what passive cooling is before we move on to our specialists here today. So my name is Ronaldo Jalil, and I'm the energy efficiency specialist attached with this global environmental facility project. So just to start off, see. Right. To start off, global temperatures on the rise. This is a snapshot of a article from the U.S. Department of Commerce saying that July of 2021 last year was actually the hottest month on record in the entire history of the planet. So yes, global temperatures on the rise, and the demand for cooling is getting greater and greater every day. So just to start off, what is passive cooling? Well, first, let me mention what active cooling is. Active cooling refers to cooling achieved through the use of technology such as air conditioners and fans. The opposite, passive cooling, on the other hand, would refer to architectural building design and building materials. Things to do with the surroundings that could be done to control the temperature within buildings. So passive cooling is generally the choices to design choices you could use to reduce heat gain in buildings, especially in hot and humid climates like Trinidad and Tobago and the rest of the Caribbean. It could also significantly increase your comfort in your home or in workplace, wherever you are, and greatly reduce your energy bills as well. Many aspects of passive cooling. For example, shading, insulation, window design can be used in home construction, building construction, and renovations. And last but not least, trees. Landscape garden design can also play an important role in passive cooling. So let's see if I could. Right. So basically, so the sources of heat in your buildings or your homes, right? What are the sources of heat? It's simply people. The more people in a room, the hotter it becomes, right? Lights to give off heat. Yeah, appliances. Certain appliances like kitchen appliances, computers, etc. will give off heat, and the largest source of heat you'll get is from the sun. It's from the sun itself, especially during the daytime. So when we're talking about passive cooling, we're referring to things you could do to improve what you call your building envelope. So think of your building envelope as everything that separates the outside environment from your indoor environment. So we're talking about your roof, your ceilings, your walls, your doors, your windows, etc. Right. A building envelope sound condition, it'll affect the operation of your cooling equipment like your air conditioners and fans, and the comfort of your occupants as well. And so it's affected by temperature, solar radiation, the weather, and heat could actually try. How does your indoor space get hot? Why do you need cooling? Is because hotter air from the outside is actually radiating through your walls and into through your walls, your ceilings, your doors, etc. Into the indoor space that you're in, making you hot and uncomfortable. So heat is gained through the walls, ceilings, and windows, etc. Changes or retrofits in the existing envelope can be, expensive, and that is why it's very important to consider, passive cooling in the design of new, in construction of new buildings, and energy management on a whole should be considered a priority in new building design and construction. So here list of some building design considerations, a summary here before I get into different ones. So external considerations when we're talking about the building envelope. Insulation on walls could help to reduce heat from the outside transferring into the inside of your building and making you uncomfortable, hot and uncomfortable. Windows, you could use like curtains and certain things to like filter out the solar radiation, and as well as being able to provide natural lighting from the sun. Roofing, install light colored roofing material, surface orientation, this refers like designing a building around like the shading of trees and vegetation. Air filtration, minimize air exchange between the conditioned space and the outdoor environment. In other words, try to see any openings in your building envelope, like cracks in your building or broken windows, etc. Try to seal them so you could prevent too much hot and humid air from entering into your building and giving your air conditioners and fans more work to do to help to cool you. And those are just the external considerations in regard to the building envelope. Internal considerations, remember things like lighting, like lights and appliances could generate heat. So for lighting, you could install like LED lighting, which is the most efficient type of lighting out there, to give off less heat, as well as install more energy efficient appliances. So going into if different passive cooling solutions you could try for like let's say for the different areas of the building envelope, starting with roofs and ceilings. Some of y'all might be familiar with the radiant barrier. I mean, I've heard that it could be pretty expensive, but I've noticed a lot of people, especially people building new homes, are considering to install it. It makes a huge difference in heat gain inside your building from this picture here. All right, and it could also save you on air conditioning and fan costs as well, cooling costs. It could help to lower, reduce the overall heat load coming into your building. So this is like the radiant barrier. You could also consider like heat reflective paints to put on your roof. White is actually the color that best reflects sunlight and solar radiation. Okay, so consider painting your roofs white, or maybe there are other colors of heat reflective paint you could try and look for. And then of course there's eaves, to help to give your building a little bit more shading. Here are a few examples here. So that's like roofs and ceilings. Windows, right? There are lots of different coverings for windows. You have curtains, the normal curtains, but you also have like shades, like and blinds as well. Shades you could pull up and down if ever you want some natural lighting. You could pull them up. If it's getting too hot inside your room, you could pull them down. You also have blinds as well. Why the reason I recommend going with blinds most of the time is because blinds can be adjusted. So you could adjust the blinds to let in as much sunlight as you want, not too much. That way you could keep you don't have your office, like your room or office space or whatever, doesn't have to become too hot, and you could get some natural lighting to do your work or other activities in your room. Okay. When speaking about windows too, there's also the option of going double paned window glass instead of the usual single pane. They have properties with them that could help in reducing the transfer of heat from the outside into the inside of your building. Now I can tell you that double pane glass is a lot more expensive than single pane glass. I'm not sure about most homeowners who would actually consider using this. Is mostly government buildings. You would see actually investing in the double pane glass. But if you could, if you have the cash to spare, I'll tell you to consider it because it can make a huge difference in how much cooling you would need for your home or small office. And for the walls, there are different building materials, many different building materials, and that you could use to build your walls with, and even put extra layers of it as well to help insulate and prevent heat transfer from the outside to the inside of your building. This is just a small list. However, there are lots and lots of building materials out there, and you can get a wealth of information on this online. Building materials come with something called an R value, which is basically a measurement of its ability to resist heat transfer. And these R values could also, this is just R value per inch, but the R values could actually increase with thickness of material. So let's say you have you're building a new building. You're using a certain type of block that has its own R value, and then you could also insulate the one side of the walls with something like maybe plywood or something. So just to call out anything, and that could help to add layers of insulation and increase your overall R value, your overall resistance to heat transfer as well. Let me just tell you a little bit about these. You'll notice that the metallic materials made out of metal have very low R values. That means heat could pass through them very easily. And the best materials I would say is like using something like gypsum or plywood. Now these materials up here, these plastic polymer materials, have the best R values and are very insulative. However, I don't want to encourage the too much use of plastics and polymer substances. But again, that's your choice. The only thing I'll tell you to stay away from is fiberglass. That could have some serious health effects from what I've heard. Okay. And then last but not least, I'll just mention a little bit about house plants. Certain plants, especially the ones that could grow in our tropical environment, they've evolved in such a way that they don't just need to absorb water through their roots. They could actually absorb water vapor from the air itself, and they could therefore act as natural dehumidifiers, and to help regulate the humidity levels in your space, as well as create some fresh air. These are some examples of some of indoor plants you should consider to have in your home or office space. Okay, some of these, I'm not sure. I believe a lot of these, like snake plant, aloe vera, are very common here in Trinidad. Some of these you might recognize. All right, so natural cooling, right? Plant trees and construct new buildings within the shade of trees. Especially try to install it when you're installing new air conditioners. Try the condenser part, which is the outdoor part of your air conditioner. Try to have it in a shaded area. Try to see if you can install it in a shaded area so you can maximize its ability to operate. Because remember, this outdoor condenser is what is releasing the heat from inside your building. Is releasing back out into out into the atmosphere. So less sunlight being exposed, the less is being exposed to sunlight, the heat from the sunlight, the better it could do its job and remove heat from your building. And I just want to say that passive solutions, could help reduce the indoor temperatures by an average of 3 to 5 degrees. And you'll reduce the energy demand, also reduce the electric bill as well. Believe me when I tell you that there's a big difference between setting your air conditioner to like 20 degrees Celsius and setting it to 25 degrees Celsius. There's a big difference in energy consumption there. And with fans too, with passive cooling solutions, you might not need to have your fan operating at the highest speed. You could dial it down to a lower speed and save on some electricity as well. All right, and this is just like a picture overview of how passive cooling is done in urban areas. There's plants growing on buildings and even on top of the roofs and things too. So that's just to show you what's being done in different parts of the world. I think this picture is a picture in New South Wales. So thank you for listening, and I'd like to pass you on to Mr. Stein Carrington now to give you his presentation. Okay, thank you for listening.
Thank you for a good presentation, Mohammed. I just joined, sorry for joining late, but I had a technical difficulties, but I'm here now to listen to the rest of the panelists, speakers. Good morning, everyone.
Good morning. Just getting into good day. So is everyone able to see screen? I assume it should be working.
Yes.
Yeah, okay, great. So my name is Stein Carrington. I'm a registered architect and currently serving as a member on the TTGPC. And the intention today is to very quickly give a snapshot into how architects are at least interpreting passive cooling and its usefulness in building design, and also trying to recognize the value of it, its application from temperate to tropical climates, and how it can offer benefits to users and operators. So what is passive cooling? I mean, some of it would have been shared with Mr. Mohammed previously, but what we're really looking at is, at least in how we've interpreted it, is that it can be defined as the use of natural to low energy methods to cooling a building or spaces within a building to a point of thermal comfort that's fit for human occupancy. And essentially that's really the goal, right? Humans occupy spaces, and ultimately you're trying to create that balance with comfortable spaces while reducing energy loads. Some core principles shared by ASHRAE would be radiant control, which takes place in the quality of the glazing and how the building is shaded externally. Air control, which talks about the loss of air in and out of a building. So how is a building bleeding in any of its openings? Enthalpy recovery, which is that exchange through material. Thermal control, which is insulation, high performance level. Mr. Mohammed shared with you some, as well as the thermal bridge elimination. So the connection between certain materials and how it transfers heat. The simple illustration to the right shows the ability of buildings to sort of have this movement of cross ventilation and how hot air naturally rises. So the why, right? Very simply, the cooling strategies really are about, it can allow for adequate ventilation and cooling of the building, which is reducing humidity. It allows for thermal capacity of the building so that there's little heat transmitted in. Why we also do it, it can control direct solar radiation and reduces the overall temperature of the building, control glare from the outside and the surroundings, providing that cooler microclimate within the building. And then, of course, the goal could eventually be to reduce the operating cost of a building. The image on the right is by architects out of New Orleans, and it really just shows how buildings that wrap in these sort of shading devices and skin are reducing some of the heat load that is applied to the actual glazing. So in this case, following on the same principles of passive building design, there's a case study in the UAE that shares that in passive cooling, design is important that all building elements should either block or rejects solar heat gain and try to keep the building cool against the heat of the summer. Passive design depends on the climatic conditions and should therefore be designed accordingly. So of course, that's another thing that we always have to consider, is that the idea of passive design is spread across a host of different climates and regions. But ultimately, similar to what Mr. Mohammed have shared, is that these are the key things that you really want to focus on. It's a high solar reflective material in terms of both the color and the material makeup. Minimum double glazing. There are now further steps in terms of the quality of glazing and capacity of what glazing can do. Incorporation of green roofs, exterior shading, similar to what we've seen on the building on the right. And then some of the technologies in direct radiant cooling, which is about actually taking cold water and running it through pipes to help reduce the ambient temperature within spaces, and therefore reflect on what Mr. Mohammed just shared about the difference in temperature reduction in mechanical cooling systems can therefore be, the dependency on that is reduced. Then there's evaporative cooling, using bodies of water to reduce the temperature within a space, and insulation, stack and cross ventilation, and then building orientation, looking at how the sun rises and sets, and looking at how buildings, where the glazing is placed on a building and how it's mediated and shaded as it interacts with the sunlight. So we're quickly gonna go into some case studies. Let's just show you how it's exhibited in architecture. This is a project in Germany, Frankfurt, designed by Foster and Partners in '97. And what it shows really is how the architect would conceive an idea of building pulling air in and up through a combination of green terraces and atrium. And then that is developed into a complex section on the right, which really talks about how it's interacting with the city. If you could see like these very small dots of people, this building is 53 stories high. It's a glimpse into what the building looks like as it's manifested. It's the idea of these green terraces that are actually providing opportunities for air to come in. And what's interesting is the details on this building is that it was designed to be naturally ventilated for 60% of the year. And this approach was expected to reduce the consumption just by 50% compared to the conventional office building at the time. But what is also interesting is that as it goes forward, the building starts to continue performing well. So it's that renewable energy as a statement from 2008, it has supplied exclusively by green energy that is derived from green energy sources. Additionally, the building is also quite smart. It uses the BMS, that's the building management system, to take heat off of the glazing of the heat that transfers onto the glazing and convert that to heat the building when in need of heat. And performance in use really suggests that this building actually outperforms because it can actually be ventilated up to 85% of the year when it was designed for 60. So passive strategies in a major, meaningful way really is yielding a lot of positive direction outside of the tropical area, and which brings us to passive cooling in the tropics, our concern. And one important thing to recognize is that ASHRAE shares that thermal comfort for the human being is really between 67 and 82 degrees Fahrenheit, which sits you somewhere around 23 degrees Celsius for that human occupancy. And this is something that we're contending with in a large portion of the world, right? The tropics go from 23 degrees north to 23 degrees south of the equator. So what do we do, right? How do we implement passive cooling effectively? In buildings, circulation takes up quite a bit of space, as well as service areas like bathrooms, small kitchen and dining spaces. So these are areas that, as architects, we are looking into finding ways where we can naturally cool these areas because they're very transient spaces. So it's not spaces that people need to inhabit for a long time. We all know that as we sit in this type of meeting, right, type of presentation right now, we want to be in a thermally comfort space. But if we have to, comfortable space, but if we have to transition into another space within the building, it's fair that we can not necessarily require that level of that temperature precisely. So those are areas that we can explore to do that in. And then this is like another look at what the term, how passive design as a response in the tropics, the term tropical bioclimate architecture is very much this, an architecture that responds through passive cooling. In Brazil, this is an element of a shading device in a circulation space. Similarly, in Florida, which is really at that transient subtropical area, but very similar conditions that we can achieve, and seeing how the skin operates to indoor circulation and sort of semi-outdoor spaces. And then in Niger, in Africa, and even as far as Indonesia, these are the other examples. On the one on the left, this system is sort of popularized, Pulitzer Prize winner Francis Carré, but Article 25 is the architecture practice that endeavors to use these double roof systems to allow for cooling at that roof level and taking that hot air off and away. And these are naturally cool spaces. And this other one is an architect's office where body of water is using evaporative cooling through a stack ventilation atrium type quality, where it's an office area on the lower level, but air is actually sucked and pulled all the way up through, creating quite clearly a comfortable space to work in. And then things that we have to be mindful of as we go forward. There's a post-respiratory disease conscious world, and then there's climate change. ASHRAE produced a paper in 2020 that specifically speaks to the challenges that came out of the pandemic. And design has to factor in building ventilation as very important, the ability to flush a building, indoor air quality as a measure of indoor air quality, and then that thermal comfort as it relates to the operation of proper hygiene. And as global temperatures rise, we recognize that maintaining that thermal comfort is quite important. So cooling loads increase, and effectively you'd want to ensure that the passive strategies are applied so that it becomes an active participant in aiding in this future challenge. So these are just some references that in terms of books that you can find online or website that you can do some digging into. ASHRAE is always a great tool. Some that's not here is GBES, which is another lovely resource. The 2030 palette is a sort of environmental challenge, sort of collection of information that can guide persons towards some resources. And the others are some books that are available on Google Books and so on. So thank you for the time, and I hope that getting a little look into how we can apply and what the architecture looks like was useful. So thank you.
Right. Thank you, Mr. Carrington, for a very Mr. Carrington, for a very insightful presentation. Thank you also for expanding a lot on the general information I gave before. So I think now I'd like to move us to our panel discussion, where I encourage attendees to put any questions you have in the question and answer box, and we'll answer them. I also want to introduce our second panelist, Mr. Mali Kwamina from Mega Interior and Construction, Mega Interior and Construction Limited. So feel free to ask questions of our panelists. So I'd like to begin. I see we already have 2 questions from the audience already. First one I'd like to ask, I think Mr. Mali Kwamina can answer this one. What are some of the innovative passive cooling solutions for homeowners that are available, most applicable in Trinidad? And some examples of where they have been applied, like green roofs, walls, and can you touch on the relative costs? So, well, Mr. Kwamina, basically, the passive solutions, building renovations can be a bit expensive, and I'm guessing people would want to know what are the easiest and least expensive options you can try.
Yes. I'm not sure about my audio, but I'm trying my best this morning. So my name is Mali Kwamina. I'm the CEO for Mega Interior and Construction Limited, and I'm very passionate about sustainability to begin with. Passive cooling is just part of sustainability. Are you all hearing me? Hello?
Yes, we're hearing you.
Yes, we're hearing you.
Right. So one of the best ways to answer the question properly for me to even benefit both environmental, social, and governance is energy efficiency type of passive cooling. You know, we can't really give no good example with Trinidad and Tobago, because Trinidad and Tobago to me now really starting their just transition. And for a good passive cooling initiative, we'll be starting with the LED lighting. Lighting is a very negative impact on passive cooling. You know, you think about it, how hot those fluorescent and mercury bulbs is actually be over your head. So what I'm trying to do is trying to just clear up a couple of things that to me is very messy, you know, in the sustainable or the green design architectural world. Carrington touched base on a lot of important stuff for passive cooling that we need to follow as steps, and that is in the biophilic design area, you know, more bringing people in harmony with nature, and as well as leadership in energy and environmental design is a very good standard and a step to take towards proper or design value passive cooling, right? I will say we look at more of the discoveries for the opportunities for passive cooling. There's a lot of opportunities for ceiling, roof, and walls, meaning thermal walls, thermal ceilings, even thermal roof. There's a lot of innovation. There's a lot of ecological products. There's a lot of technology. I can name some, for example, stretch ceiling is a very good thermal ceiling. It's resilient. So it do multiple things. They have a multi-purpose type of resource-based solution. There's AeroShield rubber roofs. There's also thermal paints that can be applied to the walls. And that's after we're looking at design, you know, after you complete your whole design concept, you pay a lot of attention to the material that you're choosing now. Mr. Mohammed, I just came in on your presentation when you was touching about, when you was touching on materials. You mentioned gypsum board and I think ply and stuff like that, but those materials are not really highly solar reflective, you know, and thermal. There's a lot of innovation and a lot of technology for us to look into now if we're looking at climate resilient passive cooling or energy efficient passive cooling. And I'm happy to help. I was told I don't have much time to actually present my presentation, so I hope that helped answer the question. But the feasible study on how much it costs, I won't be able to really answer that question right now because I don't have the data right in front of me, but there's a green building or a LEED building around the Savannah, Park East, that I think belonged to RGM, and there was a lot of lead initiative for passive cooling that take place there, where they had green walls, they had solar on top of the roof. They had a couple thermal installations. So that is good, and that is the direction that we will need to go if we really want to have a cool passive design.
Okay, thank you very much, Mr. Kwamina, for the level of detail, and you answered this question really excellently.
Thank you.
So just to move on to we have a couple more questions coming in now. One person just wants to know if you'll share the presentations, and yes, we'll give more information on that after when the presentation ends. Yes, next question, either Mr. Carrington or Mr. Kwamina. Your presentation is highlighting about new construction. However, there are some existing square block homes, buildings that have been designed with AC in mind. What are their options for change? Availability of products in Trinidad and Tobago. Traditional Iranian hot country architecture encompasses capture of outside air channeling through to cool buildings.
Yeah, okay. Well, I mean, I think one of the points that we've already come at an intersection of the development of technology and ease of building, and we moved away from methods of architecture and building technology that allowed for natural cooling of spaces. And that's something that as countries develop and go through an evolution, there's always going to be that sort of dialogue that's happening, right? So if we look at homes that were often raised on stilts, or at least raised on creating some form of air plenum below them. So the gingerbread homes of Woodbrook, even your sort of country home, right? Just the fact that they had eaves that overhung, right? The fact that they were raised on some form of stilt, and the fact that it was most times jalousie windows, louvered windows. That image is a very successful passive design in principle, right? And a lot of papers where persons have looked into the tropics and that specific application of design, that's still what resonates. So when we look at what the challenge is now with the square blocky homes, square and block that you've described, Mr. Boville, is really just investigating that combination of how you can either deal with your roof installation. So you could start with, if there's a renovation to be done to your roof, you can look at how that surface could be insulated. It's a massive surface, using either a lighter color for the roof if you're doing it, or a combination of lighter colors along with the barriers. And then also giving yourself opportunity to create areas where you don't require the air conditioning. Now, of course, you have to determine that as each person as a homeowner would have to make that decision, because it really talks about how you feel comfortable in certain spaces. But yeah, so opening you're being able to open your windows, even if it requires an overlay of security and apertures, you still want to be able to open with louvers and still have some form of grill or screen to keep yourself safe, but still allow air to consistently come in. And so that's probably a question. I'm hoping I'm answering closer to your question. And then Adelwin asked a question about the role of building certification, and therefore, and this one is major. Now, I think there's a project in Antigua that was looking at a residential scale, that was looking at lead application. But traditionally, what we found is that it's at the commercial level. The state has tried to push for sustainable ideologies in their development, and passive cooling strategies can significantly aid in the attaining of LEED accreditation. but it just represents one component, right? There are a host of other things that you can apply to acquire a LEED certification. As it moves into the residential space, it's quite easy, interestingly, for a residential home to get a LEED accreditation, because what we find is that the simple technologies that are needed for a building could actually reside in a residential home. Whereas you find that a commercial building, which has a lot more demand and a higher carbon footprint, would have a tougher time doing so. So definitely, I mean, as we apply LEED standards and get into that rigor, we can see as you pick out each of the items, and LEED has their assigned standards and certification value elements that you can use to go through and determine how you can best fit that. I think there's pathways towards that. I'm hoping I'm getting that right as well, the role of building certification. And then the professionals, of course, is that I think as we ourselves, the architects, the engineers, and the contractors, there is going to require steps between ourselves and government to start to establish either incentive-based systems where it can become more integrated, where persons actually seek out professionals to execute better working buildings, right? Because the whole idea is that the life cycle cost is what everybody would like to enjoy. You would be able to achieve buildings that are lower cost to operate. Another question is coming in from Mr. Pavils. I guess you could take that, Jaleel, and then see if we could.
Yes. So, the question was the introduction to the meeting mentioned refrigeration products. However, we do not see suppliers marketing products as eco-friendly. You do not see courts advertising fridges on the energy efficiency. When looking at ACs locally, it was very difficult to find the highest energy efficient units. Even some suppliers were not aware of SER ratings. I could give some answers on this, but with Mr. Kwamina, would you like to say something first?
Yes, please.
Yeah.
Thank you. That's a very important question to address, because refrigeration is a very high fossil fuel or decarbonization issue, and there is technology, there is innovation for that. There's even hydrogen technology for refrigeration and zero plug-in, meaning there's people with technology out in Mexico that we could bring into Trinidad and Tobago, and maybe the stakeholders need to have some type of revolutionary stakeholder meeting to let these suppliers know that it's time to make these energy efficient products available, these ecological products available. There's so much great technology for passive cooling and for energy efficient refrigeration works. And I will really be happy to help to share my ideas and some solutions after the meeting that we could share it to the wide audience, the public, the people who are asking these questions. Sorry, I really don't have anything right now for me to share.
All right. Okay, so I just want to add to this question. So yeah, this what you're referring to is the active cooling that I mentioned before. We're using technology to provide your cooling. So yes, appliance companies, or I'm not supposed to call names. So yeah, a lot of the appliance companies in Trinidad now are actually are selling refrigerators that use the very climate friendly R600A gas. And it's these type of refrigerators are already flooding the market all over the world. I mentioned some of these things in a previous webinar I did on energy efficiency for homeowners. And also when it comes the question on I know, yeah, a lot of the suppliers are not really aware of the energy efficiency metrics for air conditioners like AER and SEER. We are actually working on as part of this energy efficiency in the refrigeration air conditioning sector project. We are working on trainings for the sales professionals in these companies, so that they'll be able to properly you know, advertise and relay the information to you all who will be their customers on what is the best, what are the most energy efficient air conditioners and refrigeration and energy efficient, as well as climate friendly air conditioners and refrigerators as well. Okay. So we have time for, I don't see any more questions. We have time for, oh, sorry, yes, I do see we have time for like 1 or 2 more questions. Can you all touch on the effectiveness of filling external walls with aircrete? That's definitely a question for one of you guys.
Well, I mean, the thing about it is that there's a lot of progressive technology as it comes to combining concrete and its aggregates with either other lightweight aggregates or infusing it with air, right? Now the thing of, I think these are like another example of, you know, where you have the construction sector and manufacturers of a product not necessarily always moving in tandem with technology, right? I think there's a lot of exploration that has to happen where it can, so that it can become ubiquitous. But the technology is, to my knowledge, is relatively sound. Not specifically with aircrete alone, but there's also some ones that involve some use of reused plastic. So there's companies that have explored using waste plastic and turning that into some form of aggregate, creating a lighter weight concrete that still works well in compressive strength. And that's essentially what you really need for blockworks to operate, right? You want something that can be airtight. You want something that can deal with compressive strength, and you want something that can keep the elements outside and keep the cool, whatever thermal condition you want inside, to keep that in that regard. So the effectiveness of it, by all means, once it meets some metrics, right? It's going to need to meet the metrics of cost. It definitely is meeting a metric of reusing aggregates and other waste products, lightening the aggregate, and therefore, you know, I think definitely it's something that is going to be worth exploring and hoping that manufacturers start to integrate new technologies into mass production. Mr. Joseph.
Yes, just to touch a little bit on what Carrington just said. Carrington, lovely presentation. Thanks, brother. You know, I enjoy all the questions and how you answer them, and it was very effective for the panelists and the listeners. And just to touch a little bit on the aircrete concrete, there is a technology in block called ACC block, which is the autoclave aerated concrete manufacturing technology. And this is actually a really good technology or light aggregate, as Carrington is touching on, that our manufacturers here or suppliers here should look into. There's also cellular, I think the name of it is cellular concrete, which could be used behind fiberboards.
Mr. Carmen, we really need to close off right now. Sorry to cut you short.
All right, cool.
So, yeah, so I guess this brings us to the close of this webinar. I hope it was very insightful for a lot of you who attended. So now for the closing remarks. And oh yes, and thank you, of course, to our panelists who joined us today, and thank you for all the wealth of information you shared. So now I'd like to pass you off to for for closing remarks to Miss Huggins.
Hi, everyone. Thank you. I just see one hand was up, Mr. Shahad Hussein. I don't know if he has a question, but I will just open his mic for him to speak, just to have one more.
Okay.
Mr. Hussein?
Hi, good morning, guys.
Morning.
Hussein from Guyana. Mr. Carrington is actually based on what you were saying about the waste product. And then the other speaker before mentioned about the new technology in terms of concrete. I think there are some plants in the Caribbean with waste rubber that they normally mix. I'm not sure if this would be compatible to the energy efficient system.
Yeah. Well, I mean, I think a lot of it requires, I mean, you know, we'll be honest, not all of us as architects are able to be aware of every technology that's progressing, right? And I think ultimately it's going to be about, as with any other innovation, it has to be that it comes to market and it's able to meet criteria. In the case of off-gassing and pollutants, I think you're going to need some life cycle analysis to be able to understand how it's truly affecting, because, you know, the world has come to learn about asbestos and come to learn about the off-gassing in fiberglass, and it's so to bring in rubber into the combination within concrete and the plastics in concrete and seeing how what behavior that has in time, I think is going to be a test, right? But definitely anything that can reasonably use a waste product and integrate it into new building has a pathway forward in future construction. So it's partially answering about its application of the rubber, but I think it's positive for any use of any material that would have been discarded previously.
Okay, and one more thing for Mr. Jalil. Is it possible that you could share these slides and the other projects? I don't know if it's possible for those documents to be shared.
Yes, definitely.
Okay,
yes.
Thanks, guys. Good presentation.
Okay.
Thank you.
So I think actually we do have a couple just a couple minutes, and I just want to give the floor to Mr. Carrington and Mr. Kwamina to give you know, some closing words you'd like to share.
Mr. Kwamina, you could go first as a closer. I know he was cut before, so you could give any closing comments you wanted in his.
If you want to continue what you were saying before, I know we have to close off in a couple minutes. So.
I don't know if he's still there. Okay, well, if he's not there, I'll just close by saying thank you for having me. I was able to sort of delve into
Yes.
some. Oh, okay, so he's back. All right.
Good evening.
Right.
Yeah.
No, I'm having some problems with my internet, Carrington. Go ahead.
Oh.
It's sticking right now.
All right, no problem. Okay, yeah. So just to say that it was good to be able to delve into something that, you know, probably not out of, you know, a university experience, that we haven't been able to touch on how these things are applied, especially because Trinidad and Tobago doesn't often give the opportunity to all its professionals or even homeowners or developers and private developers giving themselves a chance to. But what I would say is that one of the things that we try to do in our practice is have a dialogue with the clients that allows them to see cost benefits in short term as well as long term plans to execute passive cooling and see how those can be integrated to create good architecture. So that's my closing comments. Thank you, guys.
Okay. Mr. Kwamina, are you there? Yes.
Yes, my closing comments is really up to applaud the work being done by Ministry of Planning and Development, Mr. Mohammed and his team, I am actually overwhelmed with the amount of work I'm seeing coming out from that ministry, the ozone layer unit. Sorry, I can't remember all the names from the team, but I always seen stuff coming up. The work you all doing with the rack, the certification for the refrigeration and AC. I think is a wonderful job, well done, put together, and will help with the refrigeration industry and our passive cooling, energy efficiency, and the work with the climate change plan, the national development plan. All these wonderful stuff is the right direction we headed in for a bright future for Trinidad and Tobago. And thank you for having me here today. Sorry I didn't get to share my presentation and really blow away the whole audience, but next time, you all could share my slide with the panelists that is here and the viewers, and probably our contact, and let us keep in contact with each other and network and collaborate and use the PPP, public-private partnership, to really get a good job done for passive cooling and passive design in Trinidad and Tobago.
Okay. Thank you very much, Mr. Carrington and Mr. Kwamina, that have you with us today. So just to close off, I'd just like to put you all on to Mr. Anselm Simon, who is a project manager for the energy efficiency and refrigeration air conditioning sector project here. So Mr. Simon.
Hi, good morning, everyone. Thanks, Mohammed, for the introduction. Thank you, everyone, for joining us in this webinar entitled Living Sustainable with Nature, Passive Cooling. You know, as Trinidad and Tobago proceeds towards playing its part in restoring our Earth by reducing the negative effects of climate change, such as global warming, we are the National Ozone Unit, UNDP, and the Project Energy Efficiency in the RSC sector. So I prudent to convey this information to you at this time, you know, to you, our valued stakeholders, regarding this topic. In a warming world, we cannot merely rely on energy-intensive cooling solutions to protect us alone, but must consider other passive cooling techniques that would help us control external and internal temperatures at low or no additional energy consumption. Right. So today I'd like to thank you, our valued stakeholders, for attending. I'd like to thank the panelists, Stein Carrington, Malik Kwamina, and our moderator, of course, Mr. Mohammed Jalil, for imparting and for sharing not only their knowledge and experiences, but also as delivered by all our panelists, their passion on the topic of passive cooling. As they spoke about international standards, applications, and techniques for internal and external temperature control using both building material and natural solutions like plants. You know, I actually like the work presented by Mr. Jimmy with the pink flowers. You know, we get a better understanding and handle on ways that we can, you know, fight against climate change using more natural solutions. We hope that this webinar is beneficial to you, our valued stakeholders, as we move forward to not only playing a part in building a sustainable Trinidad and Tobago, but also by extension, the world. Stay tuned to our social media handles, as mentioned in the chat, for other installments, other webinars where we convey the knowledge and partner with you, Trinidad and Tobago, and by extension, the group, in building a more energy efficient, environmentally friendly world. Thanks again, be safe, and see you at the next webinar.
Thank you.